Let us now move to the next topic, which is operation of non-inverting amplifier. The name non-inverting amplifier itself suggests that the input has to be given to the non-inverting terminal or the positive terminal. That is why Vi is being given to the positive terminal. Next is the resistance R1 is the one which gives the inverting terminal to the ground, or via resistance R1 the inverting terminal is being given to the ground. Next is, as the value or the potential V2 is the one which connects the non-inverting terminal to the value of input Vi, we can call V2 is equal to Vi. If V2 is equal to Vi, if this happens to be the first equation, let us now move to the next. Because of the virtual ground concept which I have explained in the previous class, V1 value and this V2 value will be equal. If V1 is equal to V2, then V1 is equal to V2 is equal to Vi, because V1 is equal to V2 and V2 is equal to Vi. That is why V1 is equal to V2 is equal to Vi. We have understood till here. Let us now proceed to the next. Like I have told, due to high input impedance of an op-amp, the current flowing into the input terminal is zero, which means nothing enters here. So the current that is flowing here follows the feedback path. If it is following the feedback path, the current I1 is equal to If. So if I1 is equal to If, then let us proceed to the finding, or let us proceed to finding the value for I1 and If. I1 is the value which is situated between two potentials across resistance R1. First one is the ground potential, second is the V1. So if I want to write the value for I1, it is 0 minus V1 upon R1. So if we find the value for I1, it is 0 minus V1 upon R1, which is nothing but minus V1 upon R1, but V1 value is equal to Vi, that is why it is minus Vi upon R1. So already I1 value is found. Let us now go for If value. If is the value which is situated again between two potentials. The first one is V1, second one is V0. So If is equal to V1 minus V0 divided by Rf. If it is V1 minus V0 divided by Rf, V1 value is Vi, so it is Vi minus V0 divided by Rf. Let us now put both the equations and let us try to solve them. So the first value is minus Vi upon R1, second value is Vi minus V0 upon Rf. So both are being put up here. One value is minus Vi upon R1 is equal to Vi minus V0 upon Rf. Here, next is we have split the terms. What we have done is minus Vi upon R1 is equal to Vi upon Rf minus V0 upon Rf. So this is written in this particular pattern. So it is minus Vi upon R1 is equal to Vi upon Rf minus V0 upon Rf. So here in this particular equation, we have considered V0 upon Rf is equal to, amongst Vi terms, Vi is being taken common, so we get 1 upon R1 plus 1 upon Rf. All this equation is derived from this. Now the next equation will be V0 is equal to, the Rf term is taken inside, this Rf term is now taken inside. So V0 is equal to Vi into Rf into, here there is a cross multiplication of terms which is being made, that is come here. It is Rf plus R1 divided by Rf into R1. So it is, if I now consider this Vi outside, we will get V0 upon Vi is equal to 1 plus Rf upon R1. Why do we get it as 1 plus Rf upon R1? By the cross multiplication, we understand that it is, here we get the terms cancelled and we will get the value 1 plus Rf upon R1. Let me try to make it more simpler for you all. This multiplication I will show. It is Rf into Rf divided by R1 into Rf plus Rf into R1 divided by Rf into R1. So as I have multiplied the terms, this and this gets cancelled. Here 1 Rf and 1 Rf gets cancelled. So it is Rf upon R1 plus 1, which is nothing but 1 plus Rf upon R1. So the gain of a non-inverting amplifier is AF is equal to V0 upon Vi, which is equal to 1 plus Rf upon R1.